Okay, good afternoon, AP Physics 2, aka Miss Bald, because she's probably the only one watching this. Hi, Miss Bald. This is going to be a single man podcast, not a presentation. There's a clear distinction. Um, but yeah, I am using Google Slides because my editing skills aren't very good. But yeah, we're going to be discussing the topic of electrostatics. I tend to think that I have a very simpleton way of understanding things that hopefully I can try to relay to people, sorry. So let's go over a quick overview of electrostatics. So there's Coulomb's law, of course. We need to know Coulomb's law and the conservation of energy. So Coulomb's law, if we look here, that's the equation. But what Coulomb's law is essentially saying in very basic terms is that the closer two charges are, the stronger the force between them. It's a very fundamental law of physics, which describes again the electrostatic force of attraction or repulsion, depending on the charges, which we will get into the behavior of charges as well. It states that again the magnitude of the force between two particles is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. So the charge that they give off has to do with their distance. The closer the two charges are, the stronger the force between them. The farther, the weaker the charge between them. Yeah, and we use Coulomb's law, of course, to calculate many different things. For example, it's used to calculate the electric field and the charge distribution, and it's important in understanding the behavior of the electric charges within the electric fields, which we're about to get into. So before we learn about fields themselves, well, let's learn about fields before we learn about the charges within the fields. So the most important thing to know when you're talking about electric fields is the law of conservation of energy. And what it states is that the total electric charge in a closed system will always remain constant, which means that the amount of electric charge that is lost by one object in the system has to be equal to the amount that would be gained by another object in the system. So essentially, the net charge of the system will never change, regardless of what happens within it. It won't change. So if we can think of the system as like a box, energy will not escape it, and the currents are just going to be constantly flowing within this box. Which, the first question you'd ask yourself is, okay, how are they moving? Which is really the whole study of electrostatics, is how are these charges moving? They are not just moving randomly. They're not just bouncing around the walls. They are constantly flowing, but the charges have different behaviors. So let's look at the charges and how they behave with this little graph here. So if we look at the red positive charge here, what we see is the direction of the arrows. They are coming outward, so they're coming out of the particle and into the field. Whereas with the negative, they are coming from the field into the particle. So one's going out, one's going in. That's how they act independently, and when they are put beside each other, of course, they will interact. And the same rules that we know with magnets that we've always known, opposites attract, likes repel, they still apply to the charges within every single electric field ever. So if we look here, for example, what do we see? We see two positive charges. And within the middle, we see this big gap here, and that is because they are repelling each other, as like charges would, and it causes the current to curve in this direction and take another path that it would have. The same thing happens when there's two negatives. They will also curve, and there will be that gap in between where the charges don't flow. And here, because they are opposite charges, we see the currents being attracted to each other. And again, remember, energy does not leave the system, it simply moves away. So just because two objects are repelling each other, that doesn't mean that the net charge will change. So if a question ever asks you, will the net charge change? No, because just because the currents are repelling each other does not mean that the net charge of the system will change. We should also talk about, I forgot to mention in the beginning, electric potential energy, which is another important concept. with electrostatics. And electric potential energy we can think of as how we think of, how we've always been taught to think of potential energy. It's stored energy, and in this case, it is the energy stored in an electric field due to the position, which again comes back to Coulomb's law. It's the energy we can think of as energy available for an electric charge to do work. The energy is proportional to the amount of charge, and it's in the potential difference of the points. We can also think of it as the energy stored in the system, which has to do with the position of the particles within the system. So again, just briefly coming back to electric charges and how they behave. Like we mentioned before, the direction of the force is dependent on the sign of the charge, but also the magnitude of the force has to do with how much charge that particular particle has. So that can be, for example, 2 coulombs, 3 coulombs, and there would be you would calculate the difference between two particles, or you would sum them up. The magnitude of the force is dependent on the strength that the electric field is dependent on the electric field that the particles create, which has to do with the particle's charge. The potential energy has to do with how far the particles are from each other, and if they are if they could be closer, then the charge would increase, meaning that the potential energy in the system is higher, and between different systems that can vary when you're comparing one system to another, which would be dependent on the size of the system, the charges of the particles, the magnitude of the particles. All those things could affect your results when figuring out the net charge of a system and possibly comparing it to another system. So yeah, thank you very much. That's electrostatics. Have a good night.